Alrighty, so a student pointed out to me this morning that I had made a foolish mistake regarding independent iterators in my week 5 part 1 lecture. I made a big deal about the idea that it was important for a class to support independent iterators, and then I did a demonstration of how this works for the list class. And here's the little demonstration that I showed. If we have a list m referring to, or the variable m referring to this list containing the items 315, and I set up MIT1 as the first iterator to m and MIT2 as another iterator, second iterator for m, these iterators, MIT1 and MIT2, are independent of each other. All right? So if I ask for the next value from the iterator MIT1, that returns a 3. And if I ask for the next iterator, or the next value from the iterator MIT2, that also returns a 3. And if I continue asking for the next value from MIT2 a couple times, that iterator proceeds forward, but doesn't have any interaction or effect on MIT1. All right. Now, so having said this, I then did not implement independent iterators for TupList. All right. So that was not so bright. Here is the TupList code that we looked at in week 5 part 1, class TupList. We need our dunder init method to create and initialize a TupList. Internally, we're using a tuple to contain the values that are in the TupList. Then we have our dunder stir method and our append method. Following that, I showed an iter function that creates and returns an iterator for the TupList, and then a next function that retrieves the next value from the TupList. Now, the silly mistake that I made here was not in realizing that self, that I was returning from iter, self is a reference to the current TupList. It's not a reference to a particular TupList iterator. And consequently, by setting up my iter function this way, every iterator that is created for TupList is in fact just a reference to the same, they're all just references to the same iterator object. They share the same internal ID and so forth. And so if I had done a demonstration of trying to use independent iterators for this implementation of the TupList class, it would have failed quite obviously and immediately. All right, so here I'm creating an iter for this TupList TL1, and this is TL iterator 1, and I'm creating another iter for the same TupList, TL iterator 2, and the question is, are these guys independent of each other? And the obvious answer is no, because TLIT1 is simply a reference to the current TupList object. All right, that's what's being returned by the iter function. TupList iterator 2, TLIT2, is also a reference to the current TupList object. So in fact, TLIT1 and TLIT2 are both references to this object TL1. And if they're both references to the same object, obviously they cannot be independent of one another. In fact, if I ask for the next value using TL iterator 1, I get back the 2. But if I then ask for the next value using TLIT2, I get back the 5, proving that TLIT2 is not independent of TLIT1. And then similarly, if I then ask for the next value from tlit1, I'd get back the 1. So by returning the current TupList object from the dunder iter method of TupList, it's not possible for these iterators to be independent of each other. We need to be more clever than this. And the way we're going to handle this is to create a subclass for TupList iterators within our TupList class. Then each individual iterator object that we create from within our TupList class will have its own independent index. The iter function in the TupList class itself will, instead of just returning the current TupList object, create and return a TupList iterator object. And then the next function will be changed to be part of the subclass rather than part of the TupList class, and it will return the correct value using that particular iterator. All right, I think I'm sure I've lost you. I'm sure I've lost you by now. So let's take a look at this revised code. All right. So actually, let me put let me leave the original code side by side with the revised code so that you can see what I've done. Now, formerly, we had the iterator method of the TupList class return a reference to the current TupList object. And we put into the current TupList object an initial index that we used into our tuple, an initial index of 0. But now what I'm doing instead is, in my iter function, which is actually on slide 9, instead of just returning self, I'm returning a TupList iterator that refers to the current TupList object. And the initialization code for the TupList iterator takes self, which is the current TupList iter object, and TupList, which is the current TupList object, sets up the iterator, the iterator's TupList instance variable to keep track of the TupList that this iterator refers to, and also set up an index of initially 0 for this particular iterator. Now that means each time I create a TupList iter object, it will refer to its own TupList, but it will have its own independent index, initially 0, independent of any other TupList iterator. Okay, now, in the original code, I had next implemented as part of the TupList class, and what we did was we checked whether the index was within the bounds of the tuple, and if it was, we obtained the appropriate value from the tuple, incremented the index, and then returned the value from the tuple. If the index was not within the bounds of the inner val's tuple, we raised a stop iteration exception to indicate that there are no more values remaining. In the new code, the next function, the dunder next function, is no longer part of the TupList class itself. It's been moved down into, let me get rid of this highlighting here. It's been moved down into the iterator subclass, the TupList iterator, the TupList iter subclass. And it does the same logic, but this time the self that dunder next receives is not the TupList. The self that dunder next receives is the TupList iter object. And so we have to say, all right, is the index within this TupList iter less than the length of the TupList iter's TupList tuple? Okay, so the TupList iterators Tuplist's tuple, we check to make sure that the index is within the length of that tuple. If it is, then we obtain the value from the tuple. So self is the TupList iter, TupList iter dot TupList dot vals sub index. That's the value we want to return. And then we increase our iterator's index and return the value. Otherwise, if the index is out of bounds, we're going to raise stop iteration. Okay, so those are the, well, I don't know whether we want to count these as 2 changes. I guess we'll count them as 3 changes. The first change is that we've created a subclass for our TupList iterators. And we have had, of course, to provide a dunder init function for that class. The second change that we made is we modified the dunder iter function for the TupList class, not to just return the reference to the TupList, but instead to return a reference to a newly created TupList iterator that refers to the TupList. Okay, so that's change number 2. And then change number 3 was that we moved the next function from the TupList class into the TupList iter class, and we had to add an extra level of dots in here to allow the iterator to access the TupList that it's referring to, or to access the TupList that is associated with it, and then access the tuple contained within that TupList. Okay, so now with this revised code, the iterators are independent. And so here on slide 10, this is the same code that we showed previously for the version of the TupList class that did not have independent iterators. But now with these changes that we've made and the introduction of this TupList iter subclass, the iterators are now independent of one another. Okay, so if I have TL1 as a tuplist containing 2, 5, and 1, and I create TL iterator 1 and TL iterator 2 as iterators on that tuplist, we can see now that these iterators are independent of each other. In fact, let me run this. Let me run both of these versions live. Here is the original TupList code. All right, so we've got dunder init that sets up our tuple, and we have both iter and next defined as methods within the TupList class itself, and the iterator being returned is actually just a reference to the current TupList object. This is the one that does not have independent iterators. So if I run this, okay, my example code within my code file works fine. And now let me create TL1 as a tuplist built from 2, 5, 1. All right, and tuple iterator 1 is an iterator from TL1. Tuple iterator 2 is an iterator also from TL1. And these are the guys that are not independent, because iter is just returning a reference to the TupList object, which is a flaw. So next TLIT1, next TLIT2. Whoops. We should have gotten a 2, but we got a 5, so they're not independent. If we ask for the next from TL iterator 1, we get a 1, and if we ask for the next from either of these iterators, now we're going to get a stop iteration error. All right, so that's the original version. Now here's the new version. Let me pull it up. All right, so here's the new version. This has the TupList Iterator subclass within TupList. And when I run this guy and execute the same code, TL1 gets TupList containing 251. TLIT1 is a iterator associated with the TupList TL1. TLIT2 is also an iterator associated with TupList TL1. But now these guys are independent. So if I ask for the next from TLIT1, I get a 2. If I ask for the next from TLIT1 again, I get a 5. If I ask for the next from TLIT2, however, I'm not going to get a 1 because it's now an independent iterator. I'm going to get back a 2. And then I'll get from that iterator a 5, and then from that iterator a 9. Oh, I'm sorry, a 1. I was looking at this 9 up here, but I get back 2 followed by 5 followed by 1. And now I'm going to get my exception. But meanwhile, the TL iterator 1 is still sitting around. And if I ask for its next value for, all right, the previous value that we got was 5. So I should get back a 1 this time. And now that iterator has also reached the end of the TupList. Okay, so I hope that that explains not only the error that I made, but also what we need to do to correct the error by creating this iterator subclass.